everyone. Today in class we studied centripetal force. We now understand the centripetal force to be the force that keeps an object traveling in a uniform circular path. Tomorrow and tonight in this video, we're going to study centrifugal force. We're going to still look at centripetal force, but delve deeper into this centrifugal force. Now, some things to consider. Is centrifugal force an actual force? Think about this as you're watching the different demos. Tomorrow, we're going to really delve deep and understand what in fact a centrifugal force is. Now, before we get started, I have linked a video. It's under the title Simpson's Video in the extras section, in the resources section. Go ahead and watch this video. This may be something that you've seen before. A motorcyclist driving in one of those big caged balls. That's something that we're going to look at, not actually do, but look at the concept of the centrifugal force. Another thing that you may be familiar with is a gravitron at a fair. If you've seen this amusement ride, you know that you stand along a circular, backing almost, and when the ride starts, you start to spin really fast. Once you reach a certain velocity, the bottom of the gravitron drops out. Now you don't fall, you stay right against the wall. How does this happen? Have you ever been on this type of ride? Have you ever thought about how this actually works? This is centrifugal forces all acting with each other. That's what we're going to look at today. So similar to the gravitron that we just talked about, let's look at that on a smaller scale, much smaller scale. Here I have a wire hanger and a penny. I took the hanger and I stretched it as far as it could go to make somewhat of a circle shape. Obviously it's not a perfect circle, but it will do for this demo. I bent the head of the hanger so that the penny would be able to easily balance on it. I stretched out the hanger, put the penny, and we're good to go. If you want to try this demo at home with me, all you need is a hanger, a wire hanger, plastic, you can't bend it, and a penny. Now, we are going to spin this. This may not work the first time, it may not work the second time. From what I've looked up and what I've tried, it may not work the first 10 times, but we're going to do it and we're going to try and be successful at it. If you try and do this at home, we are going to be spinning it. Being that it may not work, you want to make sure that you're wearing your safety goggles. In fact, let me get my safety goggles. Now we're all set. Make sure you have your safety goggles. You don't want to hurt yourself, and make sure that you're standing away from other people in your house so that you don't hit them with the penny. Let's try it. Obviously that didn't work. Let's try it again. Oh. It works! Now let me tell you guys, hopefully this stays. Oh my goodness. Oh! If you guys are able to do this at home, try it, because it's definitely not as easy as it looks to do. So that took me 10 times to get it to, not to get it to spin, but to get the penny to stay on my hanger. I'm very curious, if you do this at home, come in tomorrow, let me know how many times it took you to be successful at this. I'm interested. I am very impressed for those of you that are able to do this successfully, because it took me quite a while to try. So let's think a little about this demonstration. If you try this at home with me, then you'll have a better understanding of how exactly this worked, or how you had to hold your hand and spin your hand to make sure the penny stayed on the hanger. I want to know if velocity is a key factor in this demonstration. While I'm spinning it, do I have to spin it at a constant velocity, or do I have to spin it somewhat fast, somewhat slow? Does velocity matter? Does the constant rate of my velocity, does that matter? That's what I want to know. What do you think? Even if you didn't try it out, what do you think? Noticing how I failed and then how I was successful, what do you think? Velocity. Now, we've talked about centripetal force today in class. Tomorrow we're going to look at it a little bit more. We're going to talk about something that's near and dear to my heart, a ride that I work on in Disney World. But before we go ahead and do that, take a look at this demonstration. Replay it again if you need to, and tell me where exactly centripetal force, centripetal acceleration, centripetal motion, all of those factors, where are they in this demonstration? At the start of class tomorrow, we're going to go over that. We're going to talk all about it, how centripetal motion, force, acceleration, how it all plays into this experiment. But I want you guys to figure it out first. In order to do this experiment, you need to be in a big area. We didn't have to be outside. I originally wanted to do this experiment using some water and some snow, and I will show you guys how that worked out. It ended up not working, so we're going to, like I said before, alter our experiment, which is totally okay, because we still want to demonstrate the same concept, centrifugal force. So, I now have a piece of cardboard with an upside down plastic wine topper, and the water, as you can see, hopefully, you can see that my cardboard is all wet because of my failed experiment before. So, like I said, don't be discouraged if what you originally intend doesn't work. Just alter your experiment. That's what science is. That's what physics is all about. Just make adaptations to what you originally thought was going to work. So, now we're going to try it this way, and we'll see. I'm hoping that this works. The key here is we want to be able to spin this system so that my cup will remain on my cardboard. If that works, then we were successful. We achieved what we wanted to do. And it works.